Now we are going to try to understand in more details about the anesthetic machine. So this is the oxygen cylinder. Now I'm not going to run the machine, but I'm going to make you understand the flow of oxygen. Now follow my hands. Now imagine this is the flow of oxygen. So these two are my oxygen cylinders. One is connected at a time. So oxygen is coming from here, okay, and this is getting connected over here. Then this is going to the hypoxic alarm. See, there is a battery over here. See, there is a battery over here. This is the hypoxic alarm. So this is connected over here, and this is connected over here also. And there is a provision at the back of the machine, if you see carefully. This can be attached to a ventilator if we have to in future, okay. And there is another provision over here for the inspiratory and expiration. There are two provisions over here. These two provisions are specially to connect if you have a pipe supply for oxygen and for nitrous oxide. That is also interconnected, which is a good thing about here. Now if you see, the oxygen is coming from here, it's coming here, like this is where it is getting connected, okay, and this goes to the hypoxic alarm, which helps us to know whether the flow of oxygen is adequate, the pressure is adequate, whether it's coming or not. Then from here, this is going to the ventilator, if we have to connect to the ventilator, okay, and then again the inspiratory and expiratory. So can you see how interconnected these are? Then this is going, 1 minute, like this. It comes here, this is the hypoxic alarm, this goes here, this is going here. Now if you see, this is going here, this helps me to understand at what pressure it is coming in, what is the level of oxygen in the cylinder. We have that it over here. This helps me to understand at what pressure it is coming. This helps me to understand again the pressure over here, because I have a pipe provision for a pipe supply also over here. And then this is from here, here, and there is one. So this is also connected over here, and this from here goes to the flow meter. From here it goes to the precision vaporizer. From here, this is going to the screen pipe over here. This pipe is going here, and this is my inlet. This is where I can select a circle system or open system, and from here it goes to the patient gets oxygen, isoflurane gets anesthetized, produces CO2, this comes over here. From here it goes to the soda lime canister, CO2 gets removed, this is a scavenger valve, and then I can attach one, I can keep the valve open, connect a scavenger hose over here, like this, and have it as a passive scavenger. Okay, now the blue color connections are for the nitrous oxide, the white color connections are specially for the oxygen. This is the emergency flush valve. So when I press this, the oxygen which is coming over here, when I press it over here, what will happen is this oxygen, if you see, this is connected. When I press the oxygen flush valve, the oxygen directly comes. Now this hose is connected to this, and this is connected here to this, and this is connected over here. So when the oxygen flush valve is connected, this oxygen which was designed to go to the hypoxic alarm and the pressure gauge, and which was on the way to the flow meter, because I press this gets closed, and automatically it comes over here and refills the refilling bag. So this entire thing gets bypassed, and oxygen from the cylinder at 3 times the atmospheric pressure, because of pressing the pop-up valve, directly comes to the refilling bag. And from there it can go to the patient. Okay? Have you understood? Okay, so really very good design. It is sophisticated, but I like sophistication. Okay, because that's how we are able to keep our patients safe. And this is a really a good design, but again it comes at a price. And these pipes, and these are self-sealed. These valves are like this. Okay, so these tubes. Okay, so if something is not working, with the help of a technician, you can always see, and the more the connections, the more the leak test has to be done. You cannot use any oily, greasy things over here, okay, and these are very simple things, but again a normal person wouldn't mess with them, okay. A technician, these things are best left with the technician, and at least you should be able to know if there is a problem, whether it is safe or not. And if something is wrong, you just have to call the technician, get it fixed, and always try to spend time with the technician so that they see what they are doing, so that then you also are aware of the machine. So the machines have to be like your toys. You literally have to play with them without damaging them. Okay, that's very important. You have to literally know them at the back, like the back of your hand, like a child knows his toy. Because in an emergency, you have only seconds. That's not the time to know what's wrong. That's the time to apply all the knowledge, and that's why you need to be very familiar with your equipment, because without being familiar, you won't be able to keep your patients. Okay, thank you very much. Okay.